I have a question for you. When we have I to the first power, well, that's just equal to I. And when we have I squared, then by definition, this right here is equal to -1. And then if we have I to a third power, we can look at this as I squared times I. Well, this right here is equal to -1. -1 times I, we just get -I. And if we continue, I to the fourth power, this right here, look at this as I squared times I squared, which is just -1 times -1. Well, we just get 1, right? If you keep going though, if you look at I to the fifth power, look at this as I to the fourth power times I. This is 1, so 1 times I is just equal to I. And after this point, you can see that it's going to continue, and it's pretty much just going to be I, -1, -I, and 1, and so on, so on, so on. My question for you guys is this. Is it possible to have some power right here, right? I to some power, and then we end up with the number 2. What do you guys think? So now I'm going to find you guys one solution for this equation. Hopefully you guys don't mind. All we have to do is just take log base I on both sides, because this way you can see that this and that will cancel. We just get x by itself and use the change of base formula right here. We will get ln2 over ln I. And now we have to look at I in the polar form right here. So I is right here. We can see that the distance from here to here is equal to 1 and the angle from here to here is equal to pi over 2. So here we have ln2 on the top over ln I. It's the same as r theta. So r is 1. We just have e and I pi over 2, and you see this and that will cancel very nicely, and we have ln2 on the top over just I pi over 2 right here, right? But I don't like to be on the bottom, I want to be on the top, so let's multiply the bottom and the top by I, and then let's also multiply the bottom and the top by 2, so you can see that I times I is equal to -1, put the negative on the top, so altogether we have -2I ln2 over just a pi on the bottom. So this is a solution to this right here. Very cool, huh?